Hey folks, Mr. Ray here with our next lesson in grade 10 academic math. We're going to continue on in our quadratic unit. So we've been looking at the different quadratic equations, the different forms. We've looked at, we started with the standard, which looks like this. Then we started looking at transformations. So we actually created the vertex form by the transformations. And most recently we looked at the factored form, which we'll be looking at more today. So what we're going to do today is learn how to solve equations, quadratic equations by factoring. But the first thing, very important to understand, is the phrase solving an equation. So when you solve an equation, and it doesn't have to be quadratic, it could be lots of other types of mathematical equations. It means you're find the value of the variable. So in our case, most of the time that's x. Find the value of the variable that makes the equation true. Okay, so that's a really important thing to know. Good communication question on a test, maybe. I mean, you've seen this before in grade 9, and before. Just a simple linear equation like x plus 3 equals 5. Well, that's an equation because it's got a left side equal sign and a right side, and we want to find what value should x be so that this is actually true. It makes it a true statement. So most of us know that that's just a 2. So linear equations, I mean, they get harder, but a lot of times we can solve it in our head, whereas quadratic equations are much more difficult to do in your head. So you have to have a strategy. And we're actually going to be looking at 2 strategies. First one is solve them by factoring, and the one on the next lesson will be solving by using this new formula called the quadratic formula. Okay. Now another definition here that you might see in the textbook for homework questions, or maybe on a on a video on the internet. The roots of an equation. Well, the term roots, it's for us in grade 10, it basically means the same thing as x-intercepts, and we also call them zeros. You're going to see that quite often, and the reason why we call it 0 is because the x-intercepts are where the y value is 0, so they kind of go hand in hand. The roots actually means a bit more than this, but for our purposes, it's consider them to be all the same. Okay. Now what we're going to do, there's a really important strategy here. So before I start talking about it, if I had two things that are multiplying, so I'll just call them A, and I'm multiplying with B. A times B equals 0. That's a very powerful statement, because we know in order for this two numbers to multiply get 0, one of these or both of these have to be 0. I can't have both A and B to be non-zero, because that's impossible for them to create 0. So that's going to be our strategy with this factoring process. We're going to take our quadratic equation. For example, there's a quadratic equation there, x squared plus 2x minus 3 equals 0. And by just looking at it, you can tell it's going to be pretty hard to just kind of figure it out in your head. You start plugging in numbers to see if it works, and you give up after a while. Okay, so what we're going to do is we're going to turn that left side with the x squared, the x, and the constant. We're going to factor that like we did in the previous unit. So we're going to factor that quadratic expression on the left and return it into 2 factors that multiply, and the right side always has to be 0. And we're going to figure out our solution that way. So the first important step is to make sure you have a 0 before you factor the other side. If you had a number here, there's no point in factoring. You have to get rid of that number by adding or subtracting to both sides in order to get 0. Then you factor the other side. Okay, so let's give it a try. So first example here, solve by factoring. And for the first two, we'll check our solutions by substitution. Okay. So we check to see if we got a quadratic expression there, so that's good. We got equals 0, and that's what we need. So now the next step is to take that quadratic expression and factor it. So this goes back to your factoring skills that you've already hopefully achieved. This is a trinomial. It's got 3 terms with an x squared. It's also a simple trinomial because the coefficient of x squared is 1. And we know when we factor that, it's going to factor into 2 binomials. Each binomial starts with x. And then the other 2 numbers, the 2 numbers that go there and there, multiply to 14 and add to 9. So positive, multiply to positive 14, add to positive 9. And I'm not going to go through and do a lot of factoring work in this example. I'm assuming you know how to factor. And a lot of these you could do in your head anyways. So I know that 7 and 2 multiply to 14 and add to 9. So plus 7 and plus 2 go in the brackets. So I have my 2 factors. And now I use that fact, the a times b. If a times b equals 0, then either a is 0 or b is 0. So it must be that either that factor equals 0 or that factor equals 0. So what we do is we set each factor equal to 0. So x plus 7 equals 0. So I need an equal sign there. X plus 7 equals 0. And then to solve for x, we just subtract 7 from both sides. So x equals negative 7. So that's definitely a solution. And we do the same thing for the x plus 2 factor. So x plus 2 equals 0. And subtract 2 from both sides, we get x equals negative 2. So there's another solution. So remember with quadratics, there's really 3 possible number of solutions. Most of the time you'll get 2. I'll get 1, and sometimes you'll get none. So now when we factor, almost all the time we're going to get 2. So I want to kind of go back to the previous lesson when we learned, if we had a quadratic equation in factored form, for example, if it was y equals x plus 7 times x plus 2, that's factored form, and we could tell the x-intercepts were negative 7 and negative 2. Basically, I told you to you got to switch the sign of these numbers. Okay, well that was kind of the shortcut, and probably some of you are going, well, why does that work? Well, here's why it works, is because basically what we did with this equation here, we're actually finding the x-intercepts of this x squared plus 9x plus 14, negative 7, negative 2. That's where it comes from, because we set each factor equal to 0. So the x is usually the opposite sign with the same number. Okay, so that's why R and S are the x-intercepts from the previous lesson. Okay. I guess we should check our answer here. If you checked your answer back here, it'd be pretty obvious, because you plug a negative 7 in there, you get 0. Plug a negative 2 in there, you get 0. But maybe we messed up on the factoring. So what you really have to do is go back to the original equation and plug the numbers in. So if I plug in negative 7 first, so that's going to be negative 7 squared plus 9 times negative 7 plus 14 equals 0. So now I'm going to simplify this and see what happens. So negative 7 squared. So remember, anytime you square a negative number, positive. It's important to put the brackets around the number when you're squaring it. So this is going to be 49, and it's going to be minus 63 plus 14 equals 0. And now what I do, so I don't really have to use my calculator. I've got two positive numbers, so I'm going to add them together. 49 plus 14, that's 63, and I've got my one negative number, negative 63, and you can tell very quickly they cancel out, and I get 0 equals 0. So the fact that this is a true statement tells me that yes, indeed, negative 7 is a solution if I plug it in back in the beginning. And if I do the same thing, I've confirmed that this is a solution. I still have to confirm that the negative 2 works. So I do the same thing. I substitute negative 2 in everywhere I see an x. So negative 2 squared plus 9 times negative 2 plus 14 equals 0. So now we go through the simplifying. Negative 2 squared is 4. 9 times negative 2 is negative 18. Plus 14 equals 0. And again, positive numbers add up to 18. Negative numbers are negative 18. So 0 on this side. And again, the fact that that's a true statement tells me that indeed negative 2 is a solution. X equals negative 2 is a solution. Okay? So that's how this works. We're trying to find the value of x that makes this statement true. And by the way, when we're doing that, we're actually finding the x-intercepts of that parabola. Okay, for this one here, you can see it's not a trinomial. It's got two terms. It actually doesn't have a constant term, and it doesn't have to. The only term has to have to be a quadratic is an x squared term, a degree 2 term with a squared in it. It's not a trinomial, so we can't use simple or complex trinomial factoring. But remember what we always try to do when we factor, always try common factoring first. And in fact, both of these terms have an x, so I can factor an x out. And when I do that, I have a 2x plus 5 left over. Now what I like to do, even though I'm factoring out something small, I don't really have to have brackets there, but I like to put them there just to show that that is a factor so I don't forget about the x. Okay, and now I do the same thing I did here, set each of the factors equal to 0. So this one's done as soon as I do that, x equals 0. That's a solution. And 2x plus 5 equals 0. I got a bit of work to do here, so subtract 5 from both sides. 2x equals negative 5. Divide by 2, I get x equals negative 5 halves. Or I could, since negative 5 halves is exactly negative 2.5, I could put it as a decimal. So there's my two solutions for this. Let's check to see if it worked. So I'm going to put the word check above so you remember that this isn't part of the solution, it's just part of checking the solution. So the first number, I mean this is pretty obvious. It's 0 right away inside there, so you know it doesn't really matter what's in here. If I plug a 0 in here, I'm going to get a 5 equals 0, so that's 0 times 5. 0 times 5. Oh, you know what? I should be checking against the original equation, like I said earlier on the first example, because maybe I made a mistake on here. So let's go back to the beginning. I'm plugging x equals 0 into the original equation. So 2 times 0 squared plus 5 times 0 equals 0. Well, it's obvious both of these terms are 0. So that is a true statement. So therefore 0 is, x equals 0 is a solution. Try the same thing. This will be a little trickier because it's a decimal. I plug in negative 2.5 squared plus 5 times negative 2.5 equals 0. So negative 2.5 squared, that's going to be positive. It's going to be 6.25. And then when I double it, it's 12.5. Okay, and then this 5 times negative 2.5, that's actually negative 12.5. And you can see very quickly that those cancel each other out. And I've confirmed that x equals negative 2.5 is also a solution. So you don't have to do this every time. But if you're writing a test, and you got some time left over, it's always a good idea, because then you can walk away from the test knowing that you got some of these questions correct. Okay, last one here. This one's a little different. You can see I don't have a 0 on this side, so that's a problem. We have to correct that before we think about factoring. So I'm going to subtract 15 from both sides. And now I, subtract the equation written in this form. I've got the 0 here. Now I can factor the left side. Now this is a complex trinomial factoring, so you could use your fast factoring, intelligent guess and check, whatever method you want to call it, or you could use decomposition. It might take a little longer. Whenever you're doing a method, it's probably a good idea to kind of do the factoring part as a little aside over here, where you're doing your work, and then just put the factored version over here. So you kind of remember where you left off. So it's not a whole bunch of work here, and then you forgot what you were doing. Okay, so I'm just going to go right to the factors here. It's x minus 5, first factor, and 2x plus 3. And of course we can check that that's right. We got a 6x squared, we got a negative 15 there, a 9x and negative 10x, they combine to be a negative 1x. So that is true. And now we set each factor to 0. 3x minus 5 equals 0. So you add 5 to both sides and then divide by 3. I'll just skip a little step there. So that's going to be x 5/3 is one solution. And this one here, 2x plus 3 equals 0. Subtract 3 from both sides and then divide by 2. I get x equals negative 3/2. Okay, and just to remind you about the recurring question, can I change that to a decimal? So the answer to that is maybe. It depends on if you can change it to a decimal that's exactly the same as this without rounding or cutting off digits, then go for it. This fraction here, negative 3/2, if you put that in a calculator, negative 3 divided by 2, you get negative 1.5. Exactly. So you could replace. You could actually put this as x equals negative 1.5, no problem at all. However, this one, when you take 5 on a calculator, divide it by 3, you get 1.66666 forever. Calculator's display fills up, and that's a sure sign that I can't change that one to a decimal because it wouldn't be exact. So you have to leave this one for sure as 5/3. This one you have a choice. Okay, so there's 3 good examples on solve quadratic equations by factoring. So I've got a couple more word problems just to kind of see where we might use this type of solving quadratic equations. So here's a word problem, and this, we're going to cover some of these a couple of lessons from now. The path of a stone thrown into a ravine. A ravine is like a big valley, so it's kind of almost like a cliff, and you're throwing it into like a ravine. This actually is where a river is. So this stone's path is actually modeled by this quadratic equation. And we'll talk more about that in a second. So x represents the distance that the stone goes horizontally from the hand of the person who threw it, and y is the height, the vertical height, how high that stone is from the surface of the river. So measured from the surface of the river upwards. Okay. Question is, how far does the stone travel horizontally before it hits the water? So that's a good question. Now, the first thing you want to do in a situation like this is draw a picture. And when I do my graph for this, I'm just going to draw like 1/4 of the graph, the upper right part, and you'll see why in a second. So I look at my variables. The independent variable is x, so that's along here. And this is the distance in meters. So the more information I can put on there, the better. It's actually horizontal distance, because someone might think, oh, you mean the vertical distance? No, vertical distance is here. So the height is the vertical distance, and that's also in meters. And this corner here is 0, 0, the origin. Okay, now, first thing to notice about this quadratic equation is the a value. The a value is -1, which is obviously is negative. So what does that tell you about how it opens? It tells you it opens down. And just about every equation you get for word problems involve something going up in the air and coming back down. It's going to be opening down just like this equation is. Okay, so that's the first thing we know. It's going to be a parabola opening down. The other thing, this is in standard form. So we know that this value here is the y-intercept. So right away I can put a point on here at 84. So at 84 meters, that's where the stone is launched from. It didn't actually tell us that in the words, but we can pull that out of the equation, which is good. Okay, so I don't know. I'm not going to do any other points by plugging in at all. I'm just grabbing that y-intercept. And whenever you have a parabola and you throw something, you can assume you're throwing it upwards. So the stone's going to go upwards, and then gravity's going to take over, and it's going to plummet to the river down here. So this is the river, and we're going to find what we want to find is that distance. So we want to know how far did it travel horizontally. So now, okay, so when you want to find that point, what do you know about this point? Well, you know that the height of that stone at that point is 0. So this is like an x-intercept. So I'm going to take that equation and I'm going to set it equal to 0. I'm just going to turn it around. So I got -x squared plus 5x plus 84 is equal to 0. So this is the height. I set the y value to 0 because I want to solve for the x value here, which tells me how far horizontally the stone went. Okay, now here's a really good strategy for when you're solving a quadratic, especially like I said, you're going to see a lot of equations that have a negative value for the x squared term, and it's not very nice to solve equations where the x squared term is negative. So watch this little strategy here. So if I see a negative value for x squared, I'm going to factor that negative or -1 out of all three terms, which means all three signs flip to the opposite sign. So it's like I'm dividing each one by -1. So it turns into x squared minus 5x minus 84 equals 0. And here's a very powerful thing about the equation equaling 0. So if I want to get rid of this -1, I would divide this side by a -1. Okay, but I have to be a little careful. Like, what's going to happen over here? So if I divide 0 by -1, what happens? Well, it stays at 0. So that's a bonus because I basically can just totally ignore and just wipe it out because I'm dividing both sides by -1. So now I have a much better quadratic to factor. Okay, so you can see this is a simple trinomial. So I know that it's going to factor into two binomials, both start with x, and I for two numbers that multiply to 84, -84, and add to -5, and we could, if you wanted to, you could do the table here, the factors of 84, and figure it out that way. Or if it comes to you, well, then you go ahead and do it. So I happen to know the numbers I'm looking for are -12 and 7. So -12 plus 7 is -5. -12 times 7 is -84. So I'm just going to plug those in. You don't have to show your work if you happen to know what numbers work. So I've got my basically change this equation into factored form, and now I solve it the way I did before. Set each factor equal to 0, and this value of x is going to be 12. X plus 7 equals 0. This one will be negative 7. Okay, so I actually got two answers, but I'm only trying to find this one point. So one's negative and one's positive, so pretty sure this is 12 meters. But why did I get two answers? And the answer, well, this quadratic, I know that it's supposed to stop here and here. It knows every point, whether it's actually a valid point in the situation. So, I could just draw a dotted line here. Basically, this would be behind the person throwing the stone. And that the stone isn't going to go there because the stone is being thrown forward. But the actual equation of the parabola has two values where the height is 0, and this value here is negative 7. Okay, but that's a value that's valid because, we can't have negative values of x because the stone is going only in the forward direction. So what we do here to show that only one answer is correct, you can put a little x here. Still have to do the work, but show that this is invalid. And if you want to say because x has to be positive, that would be great. But if you just put valid with an x through, I know you considered it, but you realized it's not a real possible answer. So the answer to the question is just the 12. So since this is a word question, it deserves a word. So just read the question. How far does it travel horizontally before it hits the water? And then turn that question into an answer. Therefore, the stone travels 12 meters horizontally before it hits the water. Okay, so there's your first word problem to do with quadratics, and we used the solve-factoring technique. So that's a good first word problem. Here's another one. This one here. When you just glance at it, just like we glanced at that, you kind of scan through, oh, there's a quadratic equation. You look at this and go, there's no quadratic equation, so I don't know what I'm supposed to do. So let's read the question. A rectangle has dimensions 3x minus 1 and x plus 1. Its area is 84 centimeters. What are its actual numerical dimensions? And since it's a quadratic unit, you're going to have to either be given or create a quadratic equation. So a lot of that comes from some pretty obvious clues here. A rectangle has dimensions. It has an area. Okay, so the first thing I'm going to do is draw a little picture of a rectangle. Okay, they're so important. Now I don't expect you to know which side is which here, but since that's the 3x, I'll assume that's the bigger side. So 3x minus 1 there, and x plus 1 there. So one's the length, one's the width. Okay, and the other thing we were told is area, so I'll put that in the middle where the area is. Okay, now in terms of units, they told us that the area was centimeters squared. So that tells us that the length and width are centimeters. So just something to take note of. Okay, now how do we create a formula? So we've got area of a rectangle, right? So what's the formula for an area of a rectangle? It's the length times the width. Okay, and do we know what the length and width are? Well, between these two, one's a length, one's a width. So I'm going to update my formula. I've got a 3x minus 1 for one of them, and I multiply that with an x plus 1. Oh, and by the way, I know the area, so let's put that in instead of a. And you can see now I've just developed a quadratic equation. Now, I don't have an x squared term, but that's because this is in factored form. Okay? Now, you might think, well, this is great. We've already got it in factored form, so I can just set these to 0 and we're on our way. But that's not correct, because remember the first requirement to solving by factoring is the left side, or the other side of the factors, has to be 0. Okay, so unfortunately this is actually going to be more work, because we actually have to expand this, then subtract 84, and then factor this side again. Okay, so it's not quite as bad as it might seem, but it's not quite as easy as it might seem since it's already factored. So let's expand this out. So I'll maybe skip a line here. I got my 3x squared. I've got 3x and a minus x, so that's plus 2x. So I'm combining the outside and inside multiplications. And then the negative 1 times 1 is minus 1. Okay, so I've expanded it. Now I'm going to subtract 84. So that's 3x squared plus 2x. So minus 1 minus 84, that's minus 85. Okay, now we're where we were for some of the other questions at the beginning. We had to do a little prep work to get it so that we could factor it. So this is where you would factor it, and again, I'd probably do this factoring part over on the side here, and then just plug your factors in here to make it much more obvious what's going on. So the factors work out to be 3x plus 17 and x minus 5. So now we can set these equal to 0. 3x plus 17 equals 0. X minus 5 equals 0. And once I subtract 17 and divide by 3, I get x equals negative 17 thirds, and x equals 5 when I add 5 to both sides. Okay, so again, I got two answers. Now this is a word problem, so maybe there's some constraints that these things have, right? And it has to do with measurement. So if I have a length and a width, obviously the length and the width have to be bigger than 0. They can't be negative. So this answer here, negative 17 thirds, that's between between negative 6 and negative 7. Let's say negative 6. If I went back to this side here and plugged in negative 6 for x, that would make this side negative 5. It would also make this side negative 19. Well, that's not good, having two negative sides of a rectangle. So again, this number does not make sense in the context of the question. It made sense in terms of the factoring, but not with what our restrictions are in the rectangle. So again, invalid. So make sure you say that. So that means the x equals 5 would work, because if we plug in that, we get 6 centimeters here, and we get 15 minus 1, 14 centimeters there. Okay, and that's going to actually be part of our next step here. So if we take this x equals 5, okay, then let's just assume that the width is the top one. So the width is 3 times x, which is 5 minus 1, equals 14 centimeters. We just did that, but I'm formalizing it. The length is equal to x, which is 5, plus 1, which is 6 centimeters. Okay, and that's what the question says. What are its actual dimensions? And a good way to check, well, you know the area is the length times the width, so if we multiply 6 and 14, we better get 84, or something went wrong. And luckily, or not luckily, of course, that's what the multiplication gives you. Okay, so again, a word question deserves a word answer. So what are its actual dimensions? Therefore, the dimensions are, and usually when we mention dimensions, we just say, for example, 14 centimeters by, or you could put an x, 6 centimeters. And that tells you one of these is the length, one is the width. Okay, so that's, you had a few good questions just practicing solving equations by factoring, and then we had a couple of interesting word problems that had some restrictions on them. So in both cases, we got 2 answers. Only one of them was a valid answer for the question. So I got some homework questions for you. So give them a try. Make sure you're very capable of solving by factoring. Okay. Some of you might have to brush up on your factoring. You can see that if you don't know how to factor, you're not going to get very far. You basically stop right here because you wouldn't know where to go. So now the next lesson was the second method of solving equations by factoring. Okay, and the important one thing I didn't really talk about, if we're solving by factoring, what happens if you can't factor it? And most cases, you get a quadratic equation. It's usually not factorable. So we're going to learn a technique that will always work. And in fact, you could even use it if the equation is factorable, like these ones here. So it's a very powerful technique, but it's also takes a bit more time. So we're going to learn that the next lesson. Okay? So have a great day, and we'll talk to you in the next lesson. Have a good day.